Hello, this is my Physics 2212 Lab 4 presentation. The purpose of this lab was to compare the magnetic fields of a physical bar magnet and a simulated magnetic dipole. We used the bias of our law and magnetic field distance dependence. We used gathered physical data from a magnetometer and simulated the bar magnet in GoScript. Results were that the magnetic dipole moment was 3.6911 and n was approximately negative 2.89. The bias of our law relates the magnetic field caused by a dipole to the magnetic moment of the dipole and the distance to the observation point. Using this equation, the magnetic field on each axis through the dipole can be determined. Graphing a plot of natural log of magnetic field strength versus natural log of distance, we can use the slope and y-intercept to determine the distance dependence of the magnetic dipole. The slope in our data was n equals negative 2.89 and k equals 7.38 times 10 to the negative 7. The system in this experiment was the bar magnet and Earth's magnetic field. Surroundings were nothing significant. Components, we had a bar magnet, a magnetometer, and 2 measuring sticks. In this experiment, we measured the distance of several magnetic field strengths on the axis of the dipole. Then we measured the magnetic field strengths at points perpendicular to the magnet and at 45-degree angles. Using this data, we could calculate the magnetic dipole moment and simulate the bar magnet used for the experiment. In GlowScript, we plug in the data that we got, the magnet moment, and wrote a function to calculate the magnetic field strength at that point. And then we simulated that at 6 observation points and a 7th that's 45 degrees from the axis. So on the left, you can see the results in our Excel sheet, our graph that gives us n and k. And on the right is our results from GlowScript. Source of error. In this experiment, we assumed that the magnetometer on my phone was perfectly calibrated. However, this is probably not the case. And inaccurate measurements when dealing with a ruler stick. So, what if you hadn't compensated for Earth's magnetic field? Due to the interference from Earth's magnetic field, the measurements would be inaccurate since they were not the result solely of the bar magnet. What if you used two bar magnets stuck together end to end? The direction of the field would not change at all. However, the field strength would be roughly twice as strong at each location due to the addition of another magnet. Thank you. Have a great day.